Hi, so this video is going to be on doing the classical calculations to get pH or get hydronium ion or hydroxide ion concentrations. We're going to look at three calculations as well as how to use your calculator in order to get the correct answers. So the first type of problem we're going to look at is pH given the H plus concentration. Remember that H plus and H3O plus, these are the same. So don't get freaked out if you're given one or the other. You're going to do it exactly the same way. We're going to also look at H plus given the pH. And lastly, we're going to look at pH given the hydroxide, the hydroxide concentration, using the two methods, one using the Kw, the ionization constant for water, and the other method using pOH. So this first example is of pH given H plus concentration. You may run into this situation if you're calculating the pH of a strong acid or even a weak acid and you want to get the pH. So if I'm telling you that H plus concentration is 4.56 10 to the minus 6, the formula for pH is pH equals the negative log of the H plus. So pH equals negative log of 4.56 times 10 to the minus 6 more. So when we put this in the calculator, if you have a calculator with a line interface, like I recommend this TI-30X2S, or if you're using a graphing calculator, you will put it in this order. Remember, you are not allowed graphing calculators on the final exam, but I can't stop you from using them in the homework. So, when you're putting this in, you're going to use the negative key here. Do not use the minus. That's going to give you an error if you end up using that. So you're going to first use the negative key, then you're going to hit the log button. And then you're going to type in your number. And you're going to want to type in your number as 4.56 E. And to get the little E, you're going to use the second button and then the EE button. And then again back to the minus key, and then 6. And you should get an answer of pH equals 5.341. Make sure on whatever calculator you're using, if you're using the one I'm showing you or a different calculator, make sure you're able to get this result. If you are getting anything different, even if it's a negative sign different, you're doing something wrong. So make sure you are indeed getting exactly 5.314035.157. The sig fig rules here are the number of decimal places in the pH is equal to the number of significant figures that you had in your hydronium ion concentration. The next calculation we're going to look at is calculating the hydronium ion concentration given pH. So here I'm giving an example, pH equals 11.65. And the formula we're going to use for this is the concentration H plus is equal to 10 to the negative pH. So in the world of logs, this is the inverse of the log. by definition. So we're going to actually try to calculate h plus equals 10 to the negative 11.65. Again, when we're putting this in our calculator, the 10 to the x is right above the log key. To access it, usually you're going to have to do second to get to the 10 to the x. So we're going to put this in exactly in the order that it looks. So you're going to do second, 10 to the x. And then again, use the negative, not the minus. And then 11.65. And when you do that, you should get 2.2 times 10 to the minus 12 molar. The third type of calculation we're going to look at is pH given the hydroxide ion concentration. There are two methods we can use to do this. One, the first we'll look at is using kW to relate back to H+. Be careful not to directly plug this in and just do the negative log of this number, because pH is negative log of the H+. So let's write that down. So because we're going to have to relate the OH minus to the H plus concentration, we remember that relationship Kw is equal to H plus times OH minus, and that number is equal to 1.0 times 10 to the minus 14th. So I know I can solve this for H plus. So H plus equals 1.0 times 10 to the minus 14th over my OH minus. And if I solve this, when I solve this, I get 2.8. Hold on, I'm running out of space, so I'm going to write it below. Equals 2.85 times 10 to the minus 12th molar. And that equals my H plus concentration. Now, if I want the pH, I'm going to take the negative log of this number, 2.85 times 10 to the minus 12th. And I get a pH is equal to 11.5. So it shows that we have a basic solution. The other way we can solve this problem is using this idea of POH. The lowercase p really just represents that mathematical relationship of negative log. So I can calculate the POH, and that's equal to the negative log of the OH minus. So we do negative log So 3.5 times 10 to the minus 3. I get 2.46. Don't stop there. That is not the answer. And I promise you, if you were asked this question on a multiple choice, this will be sitting there. And it will be asking and begging for you to choose it. But you will know better, and you will keep going to finish up the problem. So we also have a relationship, and this also comes from the KW expression. It's just another way of looking at it. That 14 equals pH plus POH. So if I want to calculate pH, I can take 14 minus the POH, and that will give me my pH. And so 14 minus 2.46 equals 11.54, which should give me 11.5, which is the same answer we got using the other method, just to confirm. So those are the two ways you can calculate pH given OH concentration. This does come in handy because when you're dealing with strong bases, the OH concentration is what you will first calculate, and then you will need to go back and get the pH from that number. So those are the main ways you're going to be dealing with getting pH. I'm going to make a next video on doing pH given strong acid and strong bases. But these are the techniques you will need to calculate the pH. Let me know if you guys have any questions, and I will look forward to talking to you in the next video. Thanks, bye.